Actually, we were studying solubility. Now, I had given you this question. Everyone solved it? Ifra, Muhammad, Fawaz. Yes, sir. Okay. What is the answer, Ifra? You can give it in approximation. What is your answer? Muhammad, have you solved it?
I even wrote the question.
What you just said?
I
For,
even wrote the question, sir.
oh, I have given you this as a homework. You should solve it. What about you, Fawaz? Okay, let's start. I'm going to explain this question. Can you solve it or I should explain? Muhammad.
I can try, sir.
Okay, just try for a few minutes. Actually, other students will join soon. Just give a try and let me know if you are unable to think anything about this question. Ifra, what is your answer? Okay, Ifra, no problem. Okay. Ruslan, have you done your homework? Ruslan. What is your what is the answer? Fawaz, speak up, please.
Yes, sir.
Alright. Have you done your homework? Yes or no?
No.
Very bad. Okay. See, I'm going to solve it. KSP of CaCl2 is given. Now you can see KSP is here as 108 into 10 raised to the power minus 15. Okay. And now what volume of water is? Basically, we need to calculate volume of water dissolved in 1 gram of CaCl2. Now, we know that CaCl2 will dissociate into ions Ca plus 2 plus 2Cl minus. Just suppose the solubility of calcium is S. Okay. The solubility is Ca plus 2 is S. Then what is the solubility of 2Cl minus? It will be 2S. Any doubt in this? Now, we are going for KSP. KSP will be equal to Ca plus 2 into Cl minus to the power 2. Whatever is the coefficient that will come in power. Okay. Now again putting the value S into 2s whole square of 2s. And here you can solve since the value of KSP is given. So we have KSP that is equal to 108 into 10 raised to the power minus 15. That will be equal to 4s cube. And you will get the value of s cube that will be equal to 108 into 10 raised to the power minus 15 divided by 4. And you can cancel it by 4 to 8 and 4 7 28. And here it will be s equals to 27 into 10 raised to the power minus 15 to the power 1 by 3. And when we solve 27, you know that exponent and power you have studied in class 7th or 8th. 27 raised to the power 1 by 3. That means we can write 27 as 3 raised to the power 3. And here it is given 3 raised to the power 3 to the power 3. 1 by 3. So 3 and 3 will be cancelled. So it will be cube root of 27 that is equal to 3. 3 into and again 10 raised to the power 15 minus 15 to the power 1 by 3, that it will cancel 3 and 15, that is 10 raised to the power minus 5 will be left. So we got the value, the solubility. Okay, everyone clear with this?
Yes, sir.
Okay, now I'm going to slide it. We know that I already told you that solubility has a unit mole per liter because we express solubility in terms of mole per liter. Now this is mole per liter, that means it is molarity. It is molarity. This is basically your molarity. And molarity has a formula, number of moles of solute upon volume of solution in liter. Now again we are going to find the volume with the help of molarity. This solubility in molarity, that means this is the molarity. So we will have molarity 3 into 10 raised to the power minus 5, that will be equal to number of moles upon volume. Again we can calculate number of moles. Is my voice lagging? Saif, Ifra, Fawaz? Okay.
No, sir.
Okay, now we know that how to find number of moles, that is number of moles is equal to given mass upon molar mass. Given mass in question, it was given that 1 gram of CaCl2, that means given mass is 1 gram, that is 1, and molar mass of CaCl2 we can easily calculate. Molar atomic mass of calcium, that is 40, and atomic mass of chlorine, that is 35.5, that is 35.5 into 2. Again when you will add it up, it will be 111. So we can divide it by 111 divided by volume. And now can you calculate the value of V? Everyone, can you calculate the value of V?
Yes, sir.
Okay, please calculate it and let me know. Actually my video and the system is lagging. Let me know when you are finished. I'm going to turn off the camera and do some more. If I check it out again, will it be 10 raised to the power minus 5 or something else? Any other answer, Saf? Okay, everyone, you can see it is 3 into 10 raised to the power 5. Can I write it 1 upon 111 into V? Now again, if we are going to calculate V, we can calculate 1 by V, that will be equal to 111 into 3 into 10 raised to the power minus 5. Again, we need to calculate V, so take reciprocal both sides. So it will be 1 upon 333. I just multiplied 3 into 111 and it will be 10 raised to the power minus 5 in denominator. When it will come in numerator, it will be 10 raised to the power 5, and we can easily divide 1 upon, we can easily calculate 1 upon 333, right? Ifra, Saif,
Yes, sir.
very good. If you are done with this, let me know, everyone.
Yes, sir. Done.
Done. Can I change the slide? Moving to the next question. Which of uh, wait a minute, okay. Which of the following is most soluble? Which of the following will is most soluble? Basically, here is Bi2S. Wait a minute. Don't take Bi2S. First, I'm going to give you a very easy question. Just take example. Mx is a salt in which Ksp has a value. Ksp will be equal to 10 raised to the power minus 8. My Ksp has a value that is equal to 10 raised to the power minus 12. C Mz Ksp has a value that is equal to 10 raised to the power minus 10. And D Mn Ksp has a value that is equal to 10 raised to the power minus 16. Which of the following is most soluble? Or arrange them in decreasing order of, also arrange them in decreasing order of solubility. If Ksp is given, which salt is more soluble and which salt is less soluble? So can you solve it?
Yes, sir.
Okay, do it. Saif, is it so
Yes, sir.
hard? Can you solve it? It's so easy to calculate it within a second.
Yes, I'm almost done.
Okay. Mx is most soluble. So basically, we can also predict like the KSP which has more value. The KSP which has more value is more soluble. Okay. Or we can either calculate it. This condition will apply when similar type of salt will be there, like this will go in M plus and this will go in X minus, this will go in M plus and this will go in Y minus, this will like M plus Z minus. Similar, for similarity it will apply. The value of KSP is more, that means solubility is more. Or we can either calculate whenever different types of salt is given, then we can calculate, you know, that KSP will be equal to, since it is given 1 and 1 ions, total ions we are calculating. Can you tell me, Saif, Ifra, Fawaz and Arslan, how many ions are here and how many ions are here? Can you tell me?
Sir, 2 ions in first one and 4 in second.
4 in second, right?
Yes, according to me.
Very good. Any other answer? Please tell me, Saif, what do you think about this question?
The same, sir.
Same, because you can see 1 mole of this and 1 mole of this, that makes two ions in this. And type of ions here is two, that is Na plus and Cl minus. Again, if we are going for this, you can see 1 ion of Al plus 3, 1 ion of aluminum, and 3 ions, total makes 4 ions. Is that clear? So what I want to say is that total ions here is 2. So one ion will have solubility S and another will have solubility S. So it will be S square, and here you will get S is equal to, that will be equal to under root KSP, and you know the value of KSP, that is given basically 10 raised to the power minus 8. So it will be 10 raised to the power minus 4. Again, here we can see KSP will be equal to S square. Again, you will get the value of S under root of 10 raised to the power minus 12. So it will be 10 raised to the power minus 6. Again, you are going for this. Since two ions are present, so it will be 10 raised to the power minus 10. Is everyone getting my point? What I want to say? So it will be under root of 10 raised to the power minus 10. That will be equal to 10 raised to the power minus 5. And again, here you will get 10 raised to the power minus 8. What I want to say is that, can you tell me, we got the value of solubility for each of this, each one of this. Now, which one is more soluble? Which that means solubility which has more value of S, that means solubility is will be most soluble. So you can you tell me 10 raised to
The
the power
first,
minus 4, 10 raised to the power minus 5, 10 raised to the power basically minus 6, and 10 raised to the power minus 8. Saf, which one is greater in these four value? Which one
So
is
10
greater?
raised to power minus 4.
10 raised to the power minus 4. So basically this will be the most soluble, and you can see this will be the most soluble. And if you want to arrange it, you will see that this value A will be most soluble, then this value C, and then this value B, and then we will get D. Okay.
Okay, sir.
Yes. Please write it and let me know if you are done with this.
done, sir.
Done, everyone?
Yes, sir.
Very good.
Yes, sir, done.
Moving to the next question. Which of the following are most soluble? Bi2s, KSP has a value that will be equal to 10 raised to the power minus 23. MNS, KSP has a value that will be equal to 10 raised to the power minus 8. CUS, KSP has a value that will be equal to 10 raised to the power minus 18. Please do it and let me know the answer.
Okay, sir.
what is the value of solubility for each one of them, Fawaz? Any answer, Ifra?
So just sending one.
Okay. Ag2s. Saif,
Sir,
what is your answer?
for the first one, I'm getting 10 raised to power minus 23 by 3.
Basically, you need to calculate the value of s, right? So you are calculating the value of s, right?
Yes, sir.
Now, what you do for this, uh, just dissociate this into your mind. How many ions here will be? If you are going to do
So
this Bi2s, it will be 2Bi plus 2Bi plus bismuth, not plus 2, because sulfur has -2 charge, so it will be plus, and here it will be -2. Now again, you know that how to calculate this. This will be 2s, and this will be only s, and ksp, that will be equal to 2s raised to the power 2, because it has coefficient 2 into s. Okay, so you will get basically 4s cube will be equal to, that is 10 raised to the power -23. Okay, and it will be approximately s cube will be equal to 10 raised to the power -23 upon 4. Now what you need to do is just make sure this this power should be multiple of 3, so that it will be cancelled and you will get a good value. And now go for the second one. It will have ksp will be equal to basically s square, and you will get a value, s will be equal to 10 raised to the power -4. Now again, if you are going for this, ksp s will be equal to under root of this, because it has only 2 ions with stoichiometric coefficient 1 and 1, so it would to be other than this, and it will have value 10 raised to the power -9. Again, if you are going for this, now this will become basically 4s cube, and it will be equal to 10 raised to the power -17, and so it will be equal to 1 by 4 into 10 raised to the power -17. So you can see that the value of b, this has the value of solubility s, which is maximum, so it is most soluble. Okay, mns is most soluble. Okay, Saif.
Yes, sir.
Okay, so in short, you can say that the value with maximum value of ksp will have more soluble, will have most soluble. Okay.
okay, sir.
Is everyone done with this?
Done, sir.
Can I change the slide, Saf?
Yes, sir.
Sir, 1 minute. Done, sir.
Done. So here is another type of question which is very easy. The KSP of AGBR is 10 raised to the power minus 12. Find the solubility in water and B in NaBr. 10 raised to the power minus 2 m NaBr. Please do it. Infra, can you solve it or should I explain?
So solving that.
What you just said?
Sir, I'm solving it.
Okay. Saf,
Yes, sir.
are you solving it?
Yes, I'm sorry.
Okay.
Sir, can you do the second one,
Yes.
B part?
I'm going to explain the first part and then second part. Okay, Mohammed. Now here is water. Basically, generally we see solubility in water. So here is AgBr, a salt. If you are going to dissolve it in water, it will dissociate into ions like Ag plus and Br minus. Right. Again, you can give the solubility S. Ag plus has a solubility S as well as, since it has coefficient 1 and 1, so it will have solubility S. Now go for KSP. This is the part 1. This is the part 1. So KSP will have a value that is equal to S into S, and already the KSP has a value given 10 raised to the power minus 12. So it will be S square, and you can find the value of solubility in water, that is 10 raised to the power minus 12 under root of 10 raised to the power minus 12, and it will be equal to 10 raised to the power minus 6, right? What will be the unit? It is molarity. In terms of molarity, that means mole per liter, or m we can write. Okay, now moving for the second part. Second part is basically in the question it is given that we have to calculate the solubility of AgBr in NaBr, and NaBr has a concentration molarity that is given 10 raised to the power minus 2m. So going for B, concentrate here that AgBr will dissociate into ions into Ag plus Br minus, and you can again go for the solubility of Ag plus, that is S, and Br minus as well S. Again, if we are going for NaBr, we dissociate NaBr because it has common ion, because it will have common ion that represents the salt, which has the ions of salt is similar to the ions of solvent. Okay, so if you will dissociate this Na plus, and it will be Br minus, and it is given that NaBr has molarity that is 10 raised to the power minus 2m, that means it is 0.01 m. Again, if the molarity of or concentration of NaBr is 0.01 m, what will be the molarity of Na plus? Can anyone tell me? Ifra, Fawaz, Saif, Arslan?
So it will be same as
It will be same because both have same coefficient. Okay, both have same stoichiometric coefficient. So Br minus and Na plus will have same molarity as that of NaBr. So it will be 0.01 m. Is this clear, everyone?
Yes, sir.
Yes, sir.
Now, according to the question, we need to find the solubility. Okay, we need to calculate solubility. Okay, now, and solubility of what? Solubility of AgBr. So I'm going to apply the formula, the same formula KSP for this reaction. KSP for this reaction is basically Ag plus into Br minus. Is this clear, everyone?
Yes, sir.
Now see what will be the difference between the previous question and this question. This is a different question. You can see what is the basically these both will be in the solution, right? AgBr and NaBr, or you can say that Ag plus Br minus, Na plus and Br minus. This all will be in the solution. Is that clear, everyone?
Yes, sir.
Now, what is the concentration of Ag plus? That is given S. That is given S. Now, this is very important. Now, what is the concentration of Br minus? What is the concentration of Br minus? So,
Sir.
2, what you just said?
So 2s.
No, not 2s. This is very mad. What is the concentration of, you can see there are 2 Brs. It doesn't mean that this Br will be separate. This both Br in the same solution. That means the concentration of Br minus will increase and increases by this has a solubility S or concentration S, and this has a concentration 0.01. So the new concentration of Br minus will be S plus 0.01. Is that clear, Saif?
Yes, sir.
Ifra, Fawaz, if you
Yes,
don't
sir.
have any, if
sir.
you have any doubt, you can ask me.
No doubts.
No doubt. Ifra?
No, so clear.
Okay. So now you will go for KSP. KSP has a value 10 raised to the power minus 12, and here 10 raised to the power minus 12 will be equal to, now you can see the solubility, the value of S is very low, very low, 0.0000001. This is very small. Yes or no?
Yes, sir.
So here
Yes, sir.
I am going to neglect it, because if you are going to add 0.00001 plus 0.01, it won't affect this value. So I just neglected it, and it has a value S into 0.01. Now you can calculate the value of S. S will be equal to 10 raised to the power minus 12 upon, you can write 0.01 as 10 raised to the power minus 2. When you will solve it, you will get a value of solubility 10 raised to the power minus 10 in this, and in this NaBr. Okay, and if you are going to put it in water, AgBr dissolve in water, you will get a higher solubility because of this common ion effect. This is called common ion effect. I will show you what is basically common ion effect. This is common ion. Okay, now you will get to know why the value of solubility decreases. You can now easily connect these both points. Please write it and let me know if you are done with this. First, we are going to solve a question similar to this question. Then I will explain what is common ion.
सर
Yes,
वो 10⁻⁻12 कैसे 10⁻⁻6 लेना था नहीं
where
नहीं
I
वहाँ नहीं लास्ट s इक्वल्स नीचे हाँ
yes,
हाँ हाँ
I just kept s this side and divided by this side, divided by this. KSP has a value 10 raised to the power minus 12, right?
हाँ यस सर
And this will be equal to s into I'm going to write 0.01 as 10 raised to the power minus 2. So if I am keeping s on the left hand right hand side, it will be divided by 10 raised to the power minus 2.
यस सर
And
Okay, done everyone.
No, so wait.
Okay, take your time.
Yes, sir, done.
Okay. Now moving to the next question. And then I will explain what is common ion effect. Then we will end this chapter and we'll start hydrocarbon first and then go for S block and then P block. Okay, this is the syllabus left, right? Or is there any other chapter?
no, so these say chapters.
Okay. So everyone read about carbon, hydrocarbon.
Yes, sir.
Please do this question. Done, everyone? Do you have any deleted topics, Ifra?
Yes, sir. I will send the PDF to Anushka, sir.
Okay, good, good. Seth, are you done with this?
It's the last step.
Okay. Let me know if you're done with this. Okay, let's see. You can see KSP of Ag2CrO4 is given. We need to calculate solubility of Ag2Cr4 in Na2Cr4. So first of all, we are going to dissociate this Ag2CrO4. This will be basically 2Ag plus, and here it will be CrO4 minus 2. Now this will have a solubility 2s because it has a stoichiometric coefficient 2 and it has a stoichiometric coefficient 1, that means S. Again, we have a similar compound, that is Na2CrO4, and if you are going to see the dissociated ions, that will be basically 2Na plus CrO4 minus 2. CrO4 minus 2. Again, you can see we don't have we don't have to do anything with this, but we have to do with the common ions. So you can see this has a molarity that is 0.1 m, and so it will have molarity 0.1 m because this has a stoichiometric coefficient 1 and this has a stoichiometric coefficient 1. And if you are going to find the stoichiometric molarity of Na plus, that is basically 1 will give twice, that means 2 into 0.1. But we don't have to do anything with this. Okay, is everything okay?
Yes, sir.
Yes,
Yes,
sir.
sir.
Okay, now if you are going to find the value of ksp will have a value Ag plus into CrO4 minus 2, CrO4 minus 2. Again, Ag plus has a solubility 2s and it will have a square because it has a stoichiometric coefficient 2 into what is the solubility of CrO4 minus, that is s, and Ksp has a value 32 into 10 raised to the power minus 9. Then again, if you are going to solve the solubility, if you are going to write the solubility of CrO4 minus 2, you will see there are two, that is the one of the ions from Ag2CrO4 and one of the ion from Na2CrO4. So it will be mixed and it has a solubility that will be equal to S plus 0.1. Again, you have to neglect this solubility because it is very less. Now if you are going to solve it, it will be equal to basically how much it will be, it will be equal to 2 to the 4 s square into 0.1 into 0.1. Can you solve it now, Saif?
Yes, sir.
Please solve it. Very good. This will have a value that is basically it will be cancelled by 8 times, and if you are going to solve it, it will be 8 into s square will be equal to 8 into 10 raised to the power minus 8, right? And if you are going to take a square root, it will be 4 into 2 root 2. It will be 2 root 2, or you can write under root 8, 2 root 2 into 10
Sir,
raised to the
10
it is
raised to
4.
minus 9.
10 raised, I just solved it now. If you are going to see this for us, 8 into 10 raised to the power minus 9, this will be, and here it is s square into 0.1. 0.1 will be basically 10 raised to the power minus 1, right? And if you are going to solve it, this will be divided in the left hand side. This is 10 raised to the power minus 1, and if it goes in numerator, it will be in positive because it already has negative. So negative negative will be positive, so s square will be 8 into 10 raised to the power minus 8 na, for was.
Yes, sir. Yes. Yes.
Very good. Let me know if you are done with this.
Done, sir.
Done, everyone?
Yes, sir.
Yes, sir.
Okay, now come to the point. I'm going to define common ion, which is very easy. Now you will get everything about common ion. This too is basically example of common ion. And what is common ion effect? I have already taught you about Le-Chatelier's principle in chemical equilibrium. Do you remember? Do you remember, Ifra? Le-Chatelier's principle.
Change in any factor that determine the condition of system will cause the system to change in such manner that it will reduce the
It
effect.
reduce basically, according to Le-Chatelier's principle, if anything, any factor, if you are going to add any factor in the equilibrium state of any reaction, it will change itself in such a manner that it will nullify its effect, so that equilibrium will not change. Is that clear, Saf? If you want to change the equilibrium by adding some concentration of reactant or product, it will move in such a manner, it will go in such a manner that it will nullify or reduce the effect. Is that clear, Saf?
Yes, sir.
Now, I'm going to define common ion effect. So write it with me. It is defined as the effect on equilibrium. The effect on equilibrium. Wait a minute. That occurs when a common ion common ion, that means an ion that is already contained in the solution, that is already contained in the solution, is added to a solution. So basically, it is defined as the effect on equilibrium that occurs when a common ion is added to a solution. Now see, here is a note. Then I will explain whatever it is. Note is the common ion effect decreases solubility of a solute. Let me know if you are done with this, then I will explain this. Okay. Okay, everyone.
And done, sir.
Saf,
Minutes, sir.
Fawaz,
Done.
done. Very good.
That's
Now see, according to Le-Chatelier's principle, we already studied about it. Le-Chatelier's principle. You know that if a reaction is given, a reactant to product, basically, I just wrote it in a wrong manner. We are studying equilibrium, so it is a reversible reaction, and I'm telling you that this is at equilibrium. At this stage, you are going to add, you just for fun, you are going to add concentration of a reactant, some concentration of reactant you just add into this reaction. What will happen? This is at equilibrium. If it is at equilibrium, it will try to maintain its equilibrium, so it will move in forward direction. Is this clear? This topic actually is studied in equilibrium, chemical equilibrium. Everyone okay with this?
Yes, sir.
Yes, sir.
Yes, sir.
Now, if you are going to add some concentration of product, what will happen, sir? Concentration of product,
You move towards the reactant side.
reactant, that means left hand side. Is this clear? Now, in the same way, here is AgCl. So it will be Ag plus plus Cl minus, and you are going to take NaCl as well, not the same reactant, not the same reactant. Are you getting my point, Seth? You just in the previous question or in a chemical equilibrium, we added basically the reactant as well as product, same thing. Here AgCl is dissociated into ions Ag plus plus Cl minus in a solution, and this has achieved its equilibrium. And now you are going to add NaCl in this solution, or it will be Na plus plus Cl minus. Okay.
Yes, sir.
Now you
Yes,
see
sir.
here what happens. What happens here? The concentration of reactants increases. That's why it moves toward the right side to achieve its equilibrium, to nullify the effect. As well as when you added the concentration of product, it moves to the left side to nullify the effect and to maintain its equilibrium. So what have it doesn't I didn't say that every reactant should be added. Like if I am giving you example of A plus B will give C plus D, so you don't need to add A plus B at the same time. Either you can if you want to add A, you can add concentration of A. If you want to add the concentration of B, you can add it. But if you want to add A plus B at the same time, you can do that. So this is the common ion effect. What is common ion effect? Basically AgCl and NaCl in the same solution. Now you will see this is basically solute. We are studying about solute, and this is the uh, something you just added it. Now you will see the concentration of the this is common ion, right? This is common ion. Saif,
Yes, sir. It is.
Yes, sir.
this is common ion. Now you will see if it is common ion, then concentration of chlorine Cl minus increases on the left hand side, right? On the left hand side, concentration of Cl minus increases. Fawad, Saif.
Yes, sir.
Yes, sir.
Now what will happen? It will disturb its equilibrium, so it will move to the left hand side. It will move to the left hand side or not, Fawad, Saif?
Yes, sir.
Yes, sir.
So if it will move to the left hand side in AgCl, that means the solubility in the first case it was alone AgCl in water, so it has solubility something, just suppose solubility has 10 raised to the power minus 4. Now in common ion effect, if it will move to the left hand side, that means the reactant side, that means solubility decreases, right? Saif,
Yes. Yes, sir.
Yes.
are you getting my point? So in the same way, if you are going to watch this question, uh, with water it has a solubility 10 raised to the power minus 6, but with the common ion effect, because of the common ion effect, its solubility become 10 raised to the power minus 10 m. Okay, so with the common ion effect, basically solubility of solute, solubility of salt decreases. Everyone okay with this?
Also, please explain the example part only.
Example part, okay. So we had solved this question in two part basically, right? In water as well as NaBr, right? Sir,
Yes, sir.
so in water, you can see in water it has a solubility this. You can see basically AgBr this, and if you are going for a water has a ions which are not common with this, right? With this, it doesn't have any common ion, does it?
It does not.
Now, B part, we dissolved AgBr in NaBr, which has a common ion. Okay, so due to common ion, the concentration of Br minus increases on the right hand side.
Yes, sir.
So it will move to the left hand side to maintain its equilibrium. Okay,
Yes, sir.
so that's why in due to common ion effect, the solubility decreases or not. We have solved in water without common ion, it has solubility 10 raised to the power minus 6n. But with common ion, it has a solubility 10 raised to the power minus n. That means the solute which dissolves is very less in common ion than without common ion. Because why does it happens? Because it has some common ion which affects its equilibrium. So in order to nullify or cancel its effect on equilibrium, it will move to the left hand side. That means in reactant side. Is this clear?
Yes, sir.
Yes, sir.
FSF.
Yes, sir. Clear.
Okay, just write it and let me know. So hold.
So can you slide it down?
Yeah, I'm going to slide it down. This. Oh, okay. This is. Hold for a few minutes, please.
Okay.
Wait. Wait a minute, okay?
Done, sir.
Everyone done with this?
Yes, sir.
Okay. So this was the last part. Basically, it is common ion effect. I'm going to write some notes about common ion effects. Whatever happens here, like due to common ion effects, the solubility decreases. So in conclusion part, I'm going to write some notes. Write it with me. Due to common ion effect, due to common ion effects, solubility of salt decreases. Solubility of salt decreases. Second point we can write, as the concentration of common ion increases, as the concentration of common ion increases, solubility of salt further decreases. Solubility of salt further decreases. So basically, due to common ion effect, solubility of salt decreases, And if you increase the concentration of common ion, that means the common ion will have more concentration on the right hand side, product side. So in order to nullify the effect, or in order to cancel the effect of on equilibrium, it will move to the left hand side in more quantity. Okay, so it will have the solubility will further decreases. Is this clear?
Yes, sir.
What you just said?
Yes, sir, it is clear.
Okay, very good. So I'm going to write another important point. Or you can you can write another point. But the solubility of salt in NH4OH, the solubility of salt in NH4OH, that means the common ion effect, these will produce common ion effect, or NH3. This increases, this addition of this NH4OH or NH3 in solubility, in the solubility of salt in this increases due to formation of complex. What happens here, I'm going to explain why does it happen. Formation of complex. Please write it and let me know if you are done with this, and then I will explain it.
Done, sir.
Done, everyone?
Sir, what do you mean by complex?
Yeah, I will explain it soon. Okay, you are done with this? Are you done with this, Seth?
Yes, sir, done.
Okay. Now see what happens. I'm going to write some more points, then I will explain it. As the concentration of NH4OH, as the concentration of NH4OH or NH3 increases, then solubility of salt further increases. Now I'm going to write order of solubility of salt. Order of solubility of salt. This is very important. If you are going to dissolve salt in NH3, it will be more soluble, and even more soluble than water. If you are going to dissolve salt in NH3, and if you are going to dissolve salt in H2O, NH3 in case of NH3 will be more soluble in as compared to H2, and the list will be common ion effect. Common ion effect. So what happens here is this is a very good example. I'm going to take AgCl. Please let me know if you are done up to this point. Everyone done with this point? Up to this point?
Yes, sir.
Yes, sir.
Very good. Now see, this AgCl will first dissolve in water. Again, this AgCl is going to dissolve in NH3, KCl, first take KCl, and this AgCl you are going to take in NH3. The most dissolvable AgCl. In this case, this will be the first. There the solubility of AgCl here will be maximum, then here, and then here, because it has common ion, this Cl, this Cl. Because of effect of common ion, it will move to the left hand side. But why this NH3 will be most dissolvable or soluble in this? Why in NH3 it will be more soluble or most soluble? Because AgCl with NH3, it will make a complex compound. Complex compound, basically it is coordination compound. That is a chapter in class 12th, coordination compound in organic part, very interesting chapter. AgCl and NH3 will make a complex compound, also known as coordination compound. And generally this compound formed by, generally it is formed by D block element like iron, nickel, cobalt, chromium, zinc, like this. Some P block elements and S block elements also form, like beryllium or boron, aluminum as well, beryllium. Yeah. Now you will see here it will form complex compound, AgNH3 whole twice and then Cl minus. Because of this complex formation on the right hand side, it will decrease in concentration on the product side. That's why it will the reactant will the reaction, the solution wants to maintain its equilibrium. In order to maintaining its equilibrium, it will dissociate more and more to form the product and to nullify the effect on equilibrium. Okay.
Okay, sir.
Please write it. Done, everyone? Done, everyone?
सर एक सेकंड रुक जाओ.
Yes, I'm here.
Done.
Done, everyone?
Yes, sir.
Saif?
Yes, sir. Yes, sir.
Very good, very good. Okay, going to write a question, very good question. Think about it and answer me. You just don't need to solve it. You can do it after reading the question. Suppose the solubility of AgCl, we are talking about the salt AgCl, and we are going to make it soluble in different solvent, you can say. The solubility of AgCl, or you are going to add it in water with some other things, other compounds. Suppose the solubility of AgCl in 0.01 m NaCl, comma 0.01 m CaCl2, comma 0.01 m NH4OH, comma 0.05 m AgNO3, and water are S1, S2, S3, S4, and S5 respectively, and S5 respectively. Now the question is the correct order. Write with me. Question, write with me. Correct order. Write the correct order at the correct order of solubility of AgCl. I'm going to give you option S1 greater than S2 greater than S3 greater than S4 greater than S5. B option is S5, S4, S3, S1, S2. C option is S3, S5, S4, S5, S1, S2. D option is basically S3, S5, S1, S2, S4. Think about the question. It's so easy to do. %, it's wrong answer for us. Like you said, the answer will be 100% B. B will be the 100%. It is wrong. Speak up for us. If your answer is wrong too, for us, it's also wrong.
Sir,
C,
yes.
C is not the answer. Any answer from Saf? I told you that this NH4OH, I wrote it there, NH4OH/NH3. That means same. So the solubility will be maximum in NH3. I wrote a line in which I write like NH3 and then
Yes.
H2 and then common ion effect. Now you will see that this NH4OH exceptionally very very soluble in water, or you can say NH4OH. So this is basically S1, S2, S3 will be maximum. In S3 it will be maximum, and in water second part is S5. So if you are going to see the option S3 and then S5. Now how to decide this 1, 2 and 4 like AgCl in 0.01 m. Now if you are going to see this AgCl, it will be Ag plus and then Cl minus. Again this AgCl in NaCl. If you are going to see, NaCl has a concentration, this have same concentration, but it will affect differently because of common ion effect. You will see Na plus plus Cl minus, but you need to see what I want to tell you is that NaCl has a concentration 0.01 m. That means 0.01 m, this Cl will also have concentration, right? Is this clear, everyone?
Yes,
Yes,
sir.
sir. Yes.
So this will have the common ion effect 0.01 m. Now, if you are going to watch it carefully, you will see that for CaCl2, uh, this will be Ca plus 2 plus 2Cl minus. That means you will see that. Now I'm going to explain it again. What is the concentration of CaCl2? That is 0.01 m. But this has a coefficient 1 and this has a coefficient 2, a stoichiometric coefficient. That means CaCl2 of 1 moles will give 2 moles of 2Cl minus. That means 0.01 mole of CaCl2 will give 2 into 0.02. That means 0.01. That is 0.02. Is that clear, everyone?
Yes, sir.
Now
Yes,
see,
sir.
the common ion effect with CaCl2 will be more as compared to NaCl, right? Right or wrong?
Yes, sir.
Yes, sir.
Because on the right hand side, chlorine and the common ion effect in chlorine will have more concentration. That's why overall the reaction will move to the left hand side, reactant side, in more quantity as compared to NaCl, because the common ion in NaCl with AgCl is less in quantity, the concentration is less. Is that clear, everyone?
Yes, sir.
Now go for AgNO3. From these two, we just conclude that in NaCl more soluble than CaCl2. Okay. Okay.
Sir. Yes.
Now
Yes, sir.
again go for this 0.05. You can see 0. Does it have any common ion? Yes, it has. I'm going to slide it slightly down like this AgCl. This is Ag plus Cl minus. This is AgNO3, and it will be Ag plus NO3 minus. Now you can see here is the common ion, and this is very much large in quantity than CaCl2, than Cl minus. Is this clear, everyone? So
Yes, sir.
this common ion effect has abruptly more effect than CaCl2. That's why the more soluble is S3, then S5, then S1, that is NaCl, and then S2, that is CaCl2, and then S4, that is AgNO3, in which the common ion effect, and this has a concentration 0.05 on the right hand side, so it will move on the left hand side in more quantity than CaCl2, which has a concentration 0.02 on the right hand side, that means product, and the less quantity on the right hand side on product side is NaCl. Is this clear, everyone? Fawaz?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Wait a minute. I'm going to show you. Please write it. And let me know if we're done with this. Done. Very good, Ifra. Everyone done with this?
No, sir.
Okay. Take your time, no problem. Done, everyone?
Yes, sir.
Safe?
Sir, done.
Okay, very good. Now, we have studied in a chemical equilibrium Kc and Qc. This Kc is for equilibrium condition, and this Qc is for other than equilibrium. Do you remember?
Yes, sir.
Now, there will be a condition for precipitation in terms of Ksp and Kip. Condition for precipitation. Condition for Ksp, precipitation, Ksp is equal to Kip, solubility product, and this is ionic product. This Kip is basically ionic product. This Kip is ionic product. So whenever Ksp and ionic product is equal, there will be no PPT. No PPT, that means saturated solution. That means saturated solution. If Ksp is greater than Kip, if Ksp is greater than Kip, there will be no PPT also. No PPT, that means unsaturated solution. Unsaturated solution. And if Ksp is less than Kip, if Ksp is less than Kip, there will be PPT. There will be PPT, and it is basically super saturated solution. Super saturated solution. So in the starting of solubility, I explained about saturated solution in which no more solute can be added, unsaturated solution, as well as super saturated solution. Unsaturated solution, more solute can be dissolved, and super saturated solution in which precipitate will be formed. Is this clear?
Yes, sir.
And Ksp is basically at equilibrium. We are going to check. We are going to check the solubility, and Kip is basically at other than equilibrium. We check solubility before equilibrium, after equilibrium, not at equilibrium. Just write it and let me know if you are done with this.
Done, sir.
Done, everyone. Saif, Fawaz.
Yes, sir. Done.
1 minute, sir.
Okay, waiting for you, sir.
Done, sir.
Very good. Now, just write it KIP. KIP, and in some books it is denoted by QSP. So basically it is ionic product, and what it is, solubility product. It is basically solubility product at any time. But when we talk about KSP, that is at equilibrium only. KSP, that is equal to solubility product only at equilibrium. Only at equilibrium. Is everyone okay with this?
Yes, sir.
If 100 ml of 10 raised to the power minus 4m AgNO3 is mixed with 100 ml of 10 raised to the power minus 4m NaCl, precipitation of AgCl will take place or not, will takes place or not. Here case P is given, case P of AgCl equals to 10 raised to the power minus 10. Can you solve it? KSP is given, we need to calculate QSP or KIP in the same way that we have calculated KSP, and if it has same value then no PPT, and if only in case of KIP or QSP is greater than KSP, that way at that situation precipitate will be formed, or in case of equality to KSP or KSP is greater than KIP, there will be no PPT. Okay, Saif.
Okay, sir.
Okay,
Yes.
write the question and let me know if you are unable to solve it. Saif, Fawaz, are you there?
Yes, sir.
Can you solve this or should I explain it?
Sir, can you do a little?
Okay, so remember this formula. There is same volume whenever there is same volume, you can calculate it by the way like AgNO3, and you will dissociate into Ag plus NO3 minus, as well as then AgCl, and then you will get Ag plus as well as Cl minus. Okay, and you know this according to the question, this has 10 raised to the power minus 4m, so this will have 10 raised to the power minus 4m, as well as this will also have 10 raised to the power minus 4m. In the same uh, in the same manner we can calculate the molarity of this is given, so it will be like this and like this, or we can directly calculate whenever volume is same, we can directly calculate Ag plus will be equal to whatever is the volume into molarity into molarity or divided by total volume, that is 200. Is this clear, everyone? Saf, this is the direct shortcut. If volume is same, if volume V is same, then for the concentration is equal to this volume into molarity. That means this gives number of moles, volume into molarity upon total volume, because volume into molarity will give number of moles, and at the end number of moles divided by volume will be equal to molarity. Okay.
Yes, sir.
Okay, sir.
So okay, you can easily find the molarity of Ag plus. Can you find it? Now you can see, if you are going to calculate this value, it will be 1 by 2, which means 0.5 into 10 raised to the power minus 4, or either you can write 5 into 10 raised to the power minus 4. Again, if you are going to solve Cl minus in the same way, volume into molarity is 10 raised to the power minus 4. What from where this volume come? You know that molarity is equal to number of moles upon volume. So number of moles is equal to molarity into volume. That's why I'm doing it. And total volume is 200. Again, you will get the same value. This will be cancelled 1 by 2. We can write directly 5 into 10 raised to the power minus 5. This will have molarity. Is this clear? Is this clear, Saf?
Yes, sir, it's good.
Now going to find, either you can write QIP or QIP of AgCl. QIP of AgCl will be equal to into Cl minus, right? Ag plus into Cl minus, and Ag plus has a concentration 5 into 10 raised to the power minus 4 into Cl minus has a concentration 5 into 10 raised to the power minus 4, and this will have a concentration 25 into 10 raised to the power minus 8. Yes or no?
Yes, sir.
Sorry.
Yes.
I just wrote it wrong. The concentration is 10 raised to the power minus 5 now, if I'm taking 5. So it will be minus 5, and this will have a value which will be equal to 10 raised to the power minus 10. This is the value of QIP. And KSP has a value given in the question. KSP is equal to 10 raised to the power minus 10. Now you will see QIP is greater than KSP or not. This is KSP, this is QIP. Which value is greater? QIP. So PPT will take place. PPT will take place. I wrote every cases. If this value is greater than that, it will take place. Is this clear? Saif?
Yes, sir. Yes, sir.
Okay, just write the solution and let me know if you are done with this. Let me know if you are done with this. Saif, are you done with this?
Sir, can you go
No,
down?
sir, 1 minute.
Okay, I'm going a little bit down. Saif, are you okay with this?
Yes, sir.
Let me know if you are done with this. Okay.
Done, sir.
Okay, Fawaz. So we will have hydrocarbon in the next class. Okay. Saif, are
Okay,
you
sir.
done with this?
Yes, sir, then.
Okay. So you may leave the class. Thank you so much for today. See you in
Okay, sir.
class. Okay.
Thank you, sir.
Thank you.